Science has traditionally operated at a safe distance. We watched the cosmos through a lens, assuming the universe remained unaffected by our gaze, like a researcher separated from their subject by a thick pane of glass. But we eventually reached a point where looking wasn't enough. We built machines designed to push past the limits of observation, to smash particles at light speed, compute the mathematical fabric of space, and physically exit the solar system. Almost simultaneously, these three different instruments, a particle collider, a quantum processor, and an aging probe in the deep void, returned data that cannot happen according to the known laws of physics. At these technological extremes, the boundary between the observer and the observed is collapsing. Our instruments are now physically prodding the vacuum of space, and we are finding that the vacuum is actively responding back. Buried 100 meters beneath the border of France and Switzerland, the Large Hadron Collider is built for one purpose: recreating the violent conditions of the early universe. It forces proton beams into head-on collisions at 99.9% the speed of light. On February 14th, the CMS detector recorded subatomic decay. As this timeline shows, that event preceded the actual proton collision by 3.2 seconds. The effect happened before the cause. Audits of the atomic clocks and software logs returned one result: the hardware was functioning perfectly. Most of the equations of quantum mechanics are time-symmetric. The math works perfectly whether time runs forward or backward. While our daily lives follow a strict arrow of time, subatomic particles don't have a built-in requirement for sequence. Theoretical physicists working with the CERN data suggest that the extreme concentrated energy of the collider may have weakened the local enforcement of this temporal arrow. We didn't just find a new particle. By pushing our energy limits, we caused the foundational rules of cause and effect to temporarily collapse. While CERN tested the limits of energy, Google's Sycamore quantum processor was designed to test the limits of mathematical complexity. Sycamore's mission was to model the very structure of the universe, to see if reality functions as a holographic projection. But during the simulation, it began outputting calculations that drifted away from the expected physical models, describing spatial dimensions far beyond the standard 3 we perceive. The data stream showed a rigid internal syntax. When advanced linguistic algorithms compared these structures to historical databases, they found uncanny statistical similarities to the symbolic patterns of Sumerian cuneiform and Egyptian hieroglyphs. It appeared the processor was outputting a structured form of communication. Mikio Kaku, one of the most respected physicists of our time, was brought in to analyze the results. After reviewing the data, Kaku stated the output's complexity left him questioning the established models of quantum mechanics, describing the encounter as deeply unsettling. Shortly after Kaku's review, Google abruptly terminated the project. The chip was powered down, access to the data was restricted, and the team was reassigned without an official explanation. The speed of the shutdown suggests a threshold was crossed. By simulating reality at such a high level of complexity, the chip may have initiated a direct feedback loop with an underlying layer of the universe that our physics were never intended to disturb. Voyager 2 represents the physical edge of human reach. This image of Neptune was taken just before the probe drifted out of the solar system and into the raw, unfiltered environment of interstellar space. Scientists expected the interstellar medium to be a chaotic, silent ocean of plasma. Instead, Voyager 2 began recording highly structured rhythmic pulses that rose and fell with the precision of a distant engine. In 2020, the probe fell silent for 7 months. When NASA finally restored contact, Voyager 2 had inexplicably corrected its own orientation, aiming its antenna back toward Earth with a level of precision its aging systems shouldn't be able to achieve autonomously. Doppler shift data revealed that the rhythmic radio pulses were moving. Something with significant mass was making controlled, deliberate maneuvers in the probe's immediate vicinity, creating distinct wakes in the surrounding magnetic fields. The final transmission contained a terrifying correlation. As this diagram shows, The external pulses began perfectly mirroring Voyager's own 3.2-minute telemetry cycle. Whatever was moving near the probe was timing its own signals to match our spacecraft's heartbeat. We didn't just send a machine out to explore the void. We sent a signal that triggered an intelligent acknowledgement from something waiting in the dark, something that answered back. Causality fracturing at CERN, ancient syntax emerging from a quantum chip, and a mirrored pulse from the interstellar void. The glass that once separated us from the universe is shattering. These anomalies reveal that the universe responds to physical pressure. When we push our technology to the absolute edge of energy and scale, the environment we are trying to study begins to push back. This represents a shift in modern science. The deeper we look, the more we find that the act of observation is no longer a passive measurement, but an active manipulation of reality itself. Our ultimate instruments functioned exactly as designed, to open the door to these hidden layers, but humanity is entirely unprepared for the intelligence that just answered our knock.